Let's say that I'm given 52.0 grams of carbon dioxide, and I'm asked to determine how many moles of carbon dioxide is that equivalent to. How would I go about solving that problem? If I were given a problem where I was starting with the number of moles and I was asked what mass would that sample be equivalent to, I would need to use the molar mass for that substance. So if I'm starting with grams and I'm going to moles, I need to use the molar mass of carbon dioxide to make this conversion. So I start by writing down what I'm given, and I put that over 1. The next thing I need is my molar mass of carbon dioxide. And again, molar mass, by definition, is grams of CO2 for every 1 mole of CO2. And if I think about my units, I want to get away from the grams and I want to get 2 moles. So that means that I need to set that molar mass conversion factor up so that the grams are going to disappear. So when I look at my setup, do my grams need to go in the numerator or the denominator? Hopefully you said the denominator so that they can factor out. Now as for how many grams we have for carbon dioxide, that's where we need to go to the periodic table. So when we go to the periodic table, we see that for carbon we have a mass of 12.01 AMU. And for oxygen we have a mass of 16.00 AMU. If we look at the formula, we see that we have 1 carbon and 2 oxygens. So when we multiply and then add these up, we should end up with 44.01 AMU. Now again, when we talk about units of mass, when we talk about molar mass numerically is equivalent to the atomic mass for a single formula unit of a substance. So whereas the formula mass of CO2 is 44.01 AMU, the molar mass of carbon dioxide is 44.01 grams of CO2 for every 1 mole. Now that I have my molar mass, I can factor my gram units out, and then I can solve. When I do the math, I'm going to take my numerator, 52.0 grams, divided by the denominator, 44.01, and I'm going to end up with 1.18 moles of CO2. When I do the math, I'm going to take my numerator, 52.0, divided by my denominator, 44.01, and I'm going to come up with 1.18 moles of carbon dioxide. Let's say that I were given 3.5 moles of potassium permanganate, KMnO4, and I was asked to determine how many grams is that equivalent to. How would I go about solving that? If I were given a problem where I was given a mass of substance that I have and I was asked how many moles would that be, I would need to determine the molar mass for that substance. So in order to convert from moles of a substance to grams of a substance, I need to use that substance's molar mass value. So I'm going to start this problem by writing down the quantity that I'm given. Next, I need to set up my molar mass conversion factor. And given that I'm starting in units of moles and I want to get to grams, that means when I set up my molar mass, the mole units should be in the denominator, the grams should be in the numerator. To find the molar mass, I need to go to the periodic table and find the atomic masses for each of the elements involved. Potassium has a mass of 39.10, manganese is 54.94, and oxygen is 16.00. Looking at the formula for potassium permanganate, I can see that there's 1 potassium, 1 manganese, and 4 oxygens. So taking these into account, when I add those together, I come up with 158.04. And so this is the value that I'm going to use in my conversion. Now that I have my conversion factor set up, I can see how my moles cancel out. And when I do the math and I multiply my numerators together, I come up with an answer of 553.14, When we look for the sig figs that we should be rounding to, we see the original value only has 2, so that means that my final answer should round off to 550 grams of KMnO4. Let's say that I were given 3.2 moles of magnesium phosphate to start with, and I was asked to determine how many formula units of that ionic substance would that be. Now again, when we're talking about particles, particles can be anything from atoms to molecules to ions, or when we're talking about something that's ionic that has kind of a repeating structure of the ions in it, we refer to them as formula units, and so we're just going to call them units for the sake of this. But how would I go about solving changing from moles of something into units? If I were asked to do a conversion that started with moles and went to how many particles or formula units or atoms or ions there were in a particular substance, I would need to use Avogadro's number. So if I'm going to convert from units of moles into individual particles or units of something, I need to use Avogadro's number as my conversion factor. So I'm going to start by writing down the quantity that I'm given. And as far as my conversion factor goes, the mole units are the ones that I need to get away from. So when I set my conversion factor up, I need to set it up so that the 1 mole that Avogadro's number is equivalent to is in the denominator. Once I have those conversion factors, that conversion factor set up, I can see that my mole units cancel out. And I'm in the units that I want, so I would simply multiply the 3.2 times the 6.02 times 10 to the 23rd power and come to my answer of 1.9 times 10 to the 24th units of magnesium phosphate. Let's say that we were working with the gaseous substance hydrogen and we were told that we have 0.452 moles of hydrogen, and we're asked to convert that into what volume that hydrogen would occupy at standard temperature and pressure conditions. How would we go about solving that? If I were given the number of moles of a certain gaseous substance and asked what volume would that gaseous substance occupy at standard temperature and pressure conditions, I would need to use the molar volume as my conversion factor. So in order to convert from moles of a gas at STP into volume of gas at STP, we need to use the molar volume, which is 22.4 liters of gas for 1 mole of that gas. And that value is true no matter what the identity of the gas is. It only depends on that gas being at standard temperature and pressure. So I'm going to start with the molar value that I have, 0.452 moles of hydrogen. And I'm going to use the molar volume as my conversion factor. Given that I want to get rid of the mole units and come out with liters, I need to put the 22.4 liters on top and the 1 mole of hydrogen in the denominator. Seeing that my mole units cancel out and then calculating, I come up with an answer of 10.1248 liters of hydrogen, but we only need 3 sig figs, so that will come out to 10.1 liters of hydrogen.